All right, good afternoon, Year 10. This is stuff you have got to learn. You have to know the exact values, cosine values, sine values, trig values for 0 degrees, 30, 45, 60 and 90. Well, not for 90 for tan. I'll explain why later. Okay, so you're probably thinking, well, hang on a minute. Calculator's here, so I can just do, tan 30, and there it is, 0.577350, whatever. Okay, yeah, you're right, but there are some questions where you have to use an exact value, not a rounded value, because you would with this one have to use at some point, you'd be rounding it. All right, so we're going to look at some of those. So here we go. How do you get these exact values? Well, first of all, there you go. You've got an isosceles right-angled triangle. Okay, so it's isosceles, so I know those two lengths are the same, and I got 45 degrees there. Okay. Now, let's have a look at what we get when we do. If you use this 45 degrees down here, it doesn't matter because they're both 45 degrees, and what I've done, I've called each length 1, okay, for 1 unit. These are unit triangles, all right. So I've got 1, 1, and I suppose what I should do first of all is work out the hypotenuse using a bit of Pythagoras. So I've got 1 squared. 1 squared, well, that's easy. Okay, so it's 1 plus 1. So I know the big square is 2. How do we get back to the length? Well, I square root it. So that is square root of 2. Yeah, we're going to use surds, okay, because they are a way of expressing an exact value. So now I've got my lengths, and I know they're correct. I can start to work out my my sine, cosine and tan values for 45 degrees. So here we are. So first of all, tan 45 degrees, write it here. Which we've mentioned already. Yeah, we've mentioned already in lessons. And we know that tan 45, so that's opposite over adjacent. So opposite. Adjacent, that's the hypotenuse. Tan 45, opposite over adjacent, is 1 over 1, which is 1. Okay, we know that. We use tan values. We should be talking about tan ratio really, because the scale factor is 1. Okay, they're equal in size. So opposite and adjacent equal in size, so tan 45 is 1. Pretty easy, yeah? Okay, move on. Okay, let's get rid of that. So, we know already, I've done my Pythagoras bit, I know that's root 2. So now I'm going to do opposite, adjacent. I'm using this one, I'm using this 45 degrees down here. And that's the hypotenuse. So the sine of 45 degrees, well, sine is opposite over hypotenuse. Well, that's 1 over root 2. Op over hype. Okay, so you've got to know that. You've got to know that. The cosine of 45 degrees, which is adjacent over hypotenuse, is the same, isn't it? It's 1. It's this 1 over root 2 again. So it's 1 over root 2. And again, you've got to know that. You will have to learn that. Okay? So they're the first 3 for your 45 degrees. All right? Moving on. Right, 30, 60 degrees. Here we go. So, here's a unit triangle for an equilateral triangle. 60, 60. Yeah, just split in half there, and 60. So the thing to do is concentrate on this triangle here. All right. I could use these two to work out, use Pythagoras to work out this length here, because it's a right angle, of course. So I could do 1 squared, take away half squared. By the way, yeah, it's a unit triangle because I've got 1, 1, and 1 on the base. Okay, well, that's obviously half, and that's half. Yeah, straight away. I mean, it's a bit messy because I've got fractions like half squared. I know half squared's a quarter, and I can do 1 take a quarter, and I could write that's 3/4. But well, root 3/4 actually. But you know what? There's a better way of doing it. Here's what we do. Right, so what we do is, instead of using halves, we use ones. Great. So now, I know that is 2. Okay, because it's a 2, 2, 2 triangle. It's still equilateral. I've got 1, 1 there, and I've got 2 there. So now I can work out this length here. So just by focusing on the left triangle, this one, that's going to be, that's my hypotenuse already. So 2 squared is 4, 1 squared is 1, 4 take away 1 is 3. So this square here would be 3. Square root it, square root 3. So that is square root 3. That height. Okay. So now I've got that sussed, that's sorted. I can do things like tan 30 and tan 60, and we'll see what we get. So we'll do that. So first of all, I'll do tan 60 degrees. So if I'm using this angle here, this becomes the opposite. That's my height, and this is my adjacent. Okay, and tan is opposite over adjacent. So tan 60 is root 3 over 1, which is just root 3. Okay, have to remember that one. So yeah, on your calculator that would be, 1 point whatever, but we can just express it as root 3. It's an exact value. What else can we do? We can do tan 30, can't we? Tan 30 degrees is, all right, I need to switch around now. So tan 30 is up there is 30 degrees. So down here this is now the opposite. That's still the hypotenuse, and this becomes the adjacent. Right, so tan 30 is opposite over adjacent. That's 1 over root 3. Okay, so it's the reciprocal of tan 60. They are the reciprocals of each other. All right. Okay, move on. Right, so we'll use this one for sine, and we'll do sine 60 degrees. First of all, use this one down here. This angle here. We know this is from what we did last time using Pythagoras. Yeah, 2 squared is 4, 1 squared is 1, 4 take away 1 is 3, square root it, get square root 3. All right. Sine 60, so 60 degrees, that's the opposite. That's your hypotenuse, and that's your adjacent. So what do we got? Sine is SOHCAHTOA, sine is opposite over hypotenuse, which is root 3 over 2. So sine 60 equals root 3 over 2. Okay. Look, if you can't remember all these, and you probably won't, the easiest thing to do in an exam is draw your unit triangles. But remember, you're doing an equilateral triangle, make it 2, 2, and 2 across the bottom. Okay, 1 each half. All right. Sine 6, so sine 30 next. Now this one, we've talked about this one in class. Mentioned it a couple of times. Sine 30, so that's my angle now, so that's going to be my opposite. So let's change that. That's the adjacent. So change that one. And where are we? So it's opposite over hypotenuse, opposite over hypotenuse, 1/2, half. Okay. And we have spoken about that before in class, and we have said that when it's 30 degrees, the hypotenuse is always double the opposite. Okay. That's that one. And also, got the cosine one. Alright, it's the same triangle, so here we go. So we know from before that is root 3, and we will do cosine 60 degrees. So opposite, that's the hypotenuse, adjacent. Cosine is adjacent over hypotenuse, that's 1/2. Again, the cosine of 30 degrees, adjacent, okay, so swap them round, so that's now the opposite, that's now the adjacent, and it's going to be, where are we now, so it's adjacent over hypotenuse, root 3/2. And yep, you need to know them. You need to know them. One of these, in fact, that one gets used in question 4 on that worksheet. So I'll do something else about that tomorrow, okay? In the meantime, okay. I'll put this on. I'll put these little PowerPoint slides that I've printed off and put them on the website, which means that you can produce your own summary table of the exact values using surds. Triangles are there. Okay, so I'll leave that with you. Bye.